In this video, we're going to be covering another interview question. So Amazon wants you to calculate the top n comparators. So you have been in the like the input of the function is going to be 5 arguments. Right, I'm just going to write them down here. Okay, so there's going to be number of comparators. So let's say if we have like 5 different comparators, right? And then the second argument is going to be like they want you to return top n comparators. Let's say as an example, we're going to be returning 2 top n comparators out of 5. Then we're going to be given the list of comparators, which is going to be equal, like it's going to be an array of strings. So let's say maybe Google, maybe eBay, maybe uh, Shop Easy, uh, maybe there's could be a company name Frank, and a new company called Alex. And then we're going to be given number of reviews. Let's say the total number of reviews are 6. Then again, we definitely need the reviews itself, right? So maybe for an example, I just take 4 reviews. Someone is saying Google is awesome. Someone is saying second review is gonna be go for eBay. Then it could be Frank is my choice, and Google rocks. What's gonna happen is like out of these ones, we're gonna be crawling through them and every single review, and in the end, Google is gonna definitely gonna be in the answer. So the output is gonna be Google, right? Because came to it was mentioned two in 2 reviews. And also the problem statement does require you to ignore if it is used multiple times in the same review. So let's say Google is awesome. I am big fan of Google. Still, it will be considered. It will have the weight to get into the output is gonna be just of value 1. So the weight won't be 2, or yeah, it will, even if it is mentioned multiple times in one review, uh, it's just gonna be considered that okay, it was used one time in the review. For the other ones, we have eBay has 1 and the Frank has 1. So we're gonna be saying that both were uh, mentioned in one review. So we're just gonna take, because we can only return 2 top n comparators, so we're gonna be returning eBay only because it starts with E compared to the Frank, which starts with F. Okay. Journal, a new page after, and a new page after. Okay, nice. In terms of the algorithm, it's kind of straightforward, but it is not that straightforward. But like, it's first of all, there are a few things we're going to be doing. We are going to be creating a map here for our review. So the map is going to look like we have a Google, and initially it is mentioned 0 times. Then, or the weight of that company is 0. Then we're going to have all the companies. We're going to have eBay. Everything is going to be 0 at the beginning. Then we're going to have shopped, or what is that? Shop easy. That's not how you write easy. Shop easy is gonna initialize as 0, Frank and Alex. Then we have Frank equals to 0, Alex equals to 0. So at the end, once we iterate through these ones, right? Uh, no, once we iterate through, once we iterate through the reviews, right? Word by word, at the end we're gonna say that Google has become equal to 2, eBay as 1, shop easy as 0, Frank as 1, and Alex still at 0. After that, we need to go through all of that, right? We are again gonna have um, we have to do sorting. So if we sort based on these ones, right? Again, the sorting is going to be a custom sorting function, which is going to basically look for this value first. For some reason, the software just crashed. Okay, so we need to sort them, right? So basically, based on this value, Google is going to be at the top. And then, so basically, we need a max heap for that. And then if they are equal, we're going to say that, okay, compare them by the first character. Basically, there is in Java we have a compare to function, so we're going to be using that in order to compare this with this one. So that would bring eBay at the second, Frank at the third, and maybe Alex and shop easy. That would be the algorithm at the end for the another loop. We're gonna be just iterating up to topNCompetitors and then returning the topNCompetitors. That's it. In terms of the time complexity, so let's say the first thing we are doing is like trying to fill this up. So definitely we are gonna be using total number of n competitors. So if this is total number of competitors, right? The total number of competitors is n. The space we're gonna be using is O of n, because we do need to create a map over here. So that definitely is gonna require a space of O of n. And then in terms of anything else we are storing, we are taking one of that. Yeah, in terms of storing, we are not doing anything else. Okay, in terms of this time complexity, uh, we are iterating through every single review. So let's say if this is m, total number of reviews, like, and this is considered as reviews, so definitely O of m in order to make that map. And again, we are not saying that how many words we are iterating through, because we are going to be taking every single word. But once, if m is the number of reviews, we are going to be taking O of m. But then we also need to basically put them in the max heap. So for that one, the total number of things which are going to be added to the max heap are um, okay. Okay, so the total number of max heap, this is for that one. And then if we have n number of total competitors, that's gonna be n log of n, because we are sorting them. So the time complexity is gonna be O of m and then O of n log of n. Uh, in terms of the code, I'm just gonna be copy pasting the code here, and then we'll go through that. Okay. Okay. So again, we have been given a number of competitors, top competitors, top n competitors, right? Yeah, that's a typo. Okay, should be top n competitors, and then the list of competitors and the number of reviews and the list of reviews. We're gonna have our result, which is gonna be an array of string. We're gonna have our count, which is basically that map which says that okay, the first competitor, let's say Google, all of them are initially gonna be equal to 0 because their count or their weight is 0 at the beginning. And the set we are using to make things easy because we want to make sure that once we deal with one set, uh, 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 it's inside the set. Like once we are done with one company or one competitor, it is inside the set. Now we're gonna go through all the competitors, right, and then put them basically inside the set, but we want to make sure that they are in the lowercase. And uh, basically taking all the competitors and putting them in the set. The reason we are putting them in the set is because we want to make sure that we want to compare that. So we do want to compare that set whenever we are going to be looking at the reviews. We will be comparing that whether or not that is a thing which we are looking for or not. Initializing that we so because this is because we don't once we find one company's name inside a review, we don't wanna uh, we wanna be done with it. We don't wanna keep processing it. Okay, and then for every single review, we are splitting it with the space characters. Over here, we are going through every single word. We are looking for that word if that word is part of the set. uh, we want to process that. Also, we want to make sure that our found flag is still false. If that is the case, we want to update our all we are doing it because I'm just gonna put it here. All we are doing it because we want to update our count map. So if initializing it with 0 and every single time when you find a new competitor into a new review, it's gonna add to the previous value. And once you find that company inside the review, we're gonna set the found flag to true. Then once we are done with one review, we wanna set the found flag again to false so that we can process the next review. Once we are done with completing our this one, now we just want to put everything into a max heap. Okay, well now we just want to put everything into the max heap. So the max heap definition is that we're going to be using a priority queue, uh, max heap, and the custom lambda function is going to be that if first of all look for the count and compare them with the count. If the count is equal, then compare them with the strings, like the string characters, and then otherwise just return the -1. Okay, after that we're gonna be going through every single competitor because the total number of counts are gonna be total number of competitors, and we're gonna be putting them in the max heap. And the last thing we want to do is for the total number of n competitors, we want to go through our max heap and basically take out the maximum element based on this function, this lambda function. We want to do that, and then we're going to be returning the result, which is going to have total number of uh, top n competitor elements. We already discussed the time and space complexity. um, that would be it for this video. Thanks for watching.